Hello and welcome back to another video. Today I am going to be talking about probability. Probably, perhaps. Meh. Anyway, so today I'm going to be talking about arguably the most important theorem and formula in probability, Bayes theorem or formula, because I said it. Okay, so I'm going to derive it for you in a very intuitive way. So it'll be really fun. Check it out. Okay, so before explaining Bayes theorem or deriving it, let me first explain what conditional probability is, because that is directly related to the Bayes theorem. Okay, so what is conditional probability? So, well, it is basically like when you have two events which will happen one after the other, and the event of the second event's outcome is dependent on the first event's outcome. So let me give an example, it'll be easier to understand. So suppose you're playing a game and then you first toss a coin, so the outcome is either heads or tails. Then this is event A, event 1 or event A, event 1. And now suppose now the rule of the game says if you get heads, you will toss one coin, you will roll a dice and you will note the outcome. Okay, so you roll a dice, and if you get tails, you will roll two die and note the sum of the outcomes. And if the final number you get is 6, then you win the game, else you don't. So we need to find the probability that we will win the game. So let me remove this. Okay, so this is the chart for winning the game. This is one path, you either get a heads and get the number is equal to 6, or you get tails and get the sum of the two numbers is equal to 6. So now how will we find the probability? And oh yeah, by the way, this is event 2, and the second event is dependent on the event 1, as we can see, because if event 1's outcome is heads, we will roll one dice, and if it is tails, we will roll two die. So what is the probability of heads coming? That is 1 by 2. Okay, that is fairly simple, and so the probability of tails is also 1 by 2. Now for this, suppose you got a heads, so what is the probability that the number you will get on the dice is 6? Well, there are six outcomes which can come, 1, 2, 3, 4, 5 and 6, and this is one of the possible outcomes, so 1 by 6. Now what is the probability that the sum will be 6? Well, there are you have two dices and there are total 6 into 6 outcomes you can get. So there are total 36 possible outcomes, and how many of them will have 6 as a sum? Well, 1, 5, 2, 4, 3, 3, 4, 2 and 5, 1. So that is 5 divided by 36. Okay, so this is the probability that the sum is going to be equal to 6. So now if you see that you either get a head and number is equal to 6, or tails and sum is equal to 6. And if you remember, probably basically a first class from probability, and means that both the events have to happen together, so you multiply the probability. So this is 1 by 2 into 1 by 6, and or is plus 1 by 2 into 5 by 36. So you get the probability as 1 by 12 plus 5 by 72, which is basically 11 by 72. So this is the probability that you will win this game. Now the final outcome does not need to be the same. Like, it can also be if you get a heads and you roll a dice, you get the number as 2, or if you get tails and you get the sum of the number as equal to 10, you can use the same idea. Okay, so now for the main thing of what conditional probability is. So now, well, I'm just going to take this question. So now what is the probability of, well, conditional probability is generally given by this probability of A given that B has already occurred. So now what is the probability of 6 given that heads has already occurred? So now you know that heads has occurred. So now what is the probability that you will get 6? So now if heads occur, you will roll 1 dice. And so the probability of getting 6 on as the face of one of the dice is 1 by 6. So this is equal to 1 by 6. Similarly, probability of 6 given that tails has occurred is 5 by 36, because tails has already occurred. So now you will have to roll 2 dices. But now suppose you want to find out, like suppose you're given that the final outcome is 6 and you want to find out that the probability that the first, or let me phrase it in a much easier way. Suppose you are playing it on a computer and you just hit enter and it will go through this whole loop and return the final output. So if it's heads, it will return the number on the dice, or if it's tails, it will return the sum of the two numbers. So now suppose you get the final output as 6, and now you want to find out the probability that the output of event A, heads or tails, is tails. So that is basically probability of tails given that 6 has occurred. So you want to find this. Now for this you will need Bayes theorem, which I will derive right now, which I will explain right now. So now let me explain it in using Venn diagram, which is one of the best way to prove anything in probability. So well, so here let's say you have, this is set A and this is set B, and this is the universal set, and you need to find probability of A given that B has already occurred. So now you know that the final outcome is inside this set, this one set called B. So now you know that B has occurred, and you need to find the probability that A will occur. So now if you know that B has occurred, this part of A is not going to occur because that part is not inside B. This is sounding a little complicated, but try to keep up. So now this might seem like magic, but so now I'm going to give you one more question. This is fairly simple. Suppose you're playing darts with your friends, and now the area of the rectangular board is 100 units square, and the main target is a circle, and that is 10 units square. And suppose this is a magical world where your dart will never go outside the boundary. So what is the probability that you will hit the target? Well, it is area of the target divided by the area of the board. So this is 1 by 10, right? Now that is a similar idea what I'm going to use for this. So now you know that B has occurred, so all the possible values which can occur are in B. So this is the new universal set, which is B, and this is the tiny part of A which can occur, and this as we know is A intersection B, the part of A and B which intersect. So now the probability that A will occur only lies within this region. So the probability that A will occur is basically the area of A intersection B divided by the total area of B, or the probability P of A intersection B divided by P of B. Because this is to ease things a little bit, but eventually both are the same thing, because we can divide both sides by the total universal set, and this thing also divided by the universal set. So the number of outcomes of B divided by the elements in the universal set is the probability of B, or we can divide that the area of the universal set, which is basically the same thing for this. So that's why we get probability of A given that B has occurred is equal to probability of A intersection B divided by probability of B, and this is the Bayes theorem. Now this might seem complicated, but if you visualize about it and think more about it, it will become pretty easy and maybe apparent to some. So I hope you all enjoyed this video, and if you did, please like, share and comment on my video. Please share it to your friends, and for more such content, please subscribe to my channel. Thank you.